I wanted to do an introductory video on sine, cosine, and tangent. These are only going to be sine, cosine, and tangent when we're talking about evaluation at an angle on a right triangle. So let's suppose we have a right triangle like so, and we'll say this is A, this is B, and this here is angle C. Notice in particular that angle C is a right angle. Conventionally, people like to suppose that the length of the side opposite a capital letter here is the corresponding lowercase letter. So opposite big A is going to be the side length little a. Opposite big B is going to be the side length little b. And opposite big C is going to be the side length little c. All right. Now the way a lot of people learn what ratios correspond to what trig function is through SOHCAHTOA. All right, so this means sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Now, in terms of this picture, we have that sine, say, of A is going to equal, we have opposite big A is little a, and then the hypotenuse is little c. Cosine of big A is equal to the adjacent to big A, which is B, over C. And then tangent of big A is equal to opposite of big A is little a over adjacent to big A, which is B. Okay, now if we're talking about angle B, we have that sine of big B is equal to the opposite of big B, which is little b, over the hypotenuse, which is still C. Cosine of big B is going to equal the adjacent to big B, which is A, over the hypotenuse, which is C, because it's opposite 90, and then tangent of big B. That is going to equal the side opposite big B, which is little b, over the side adjacent to big B, which is A. Okay, so that is the ratios. Let's try an example. So our problem here is find sine, cosine, and tangent evaluated at x. So from what we know before, sine of x is going to equal the side opposite x, which in this case is 3, over the hypotenuse, which is 5. Cosine of x is going to be the side adjacent to x, which is 4, over the side which is the hypotenuse, which is opposite 90 degrees, so that's going to be 5. Tangent of x is going to equal the side opposite x, which is 3, over the side adjacent to x, which is 4. For our last example, we're going to find sine, cosine, and tangent evaluated at 30 degrees. If you watched my video on 30, 60, 90 special right triangles, you would know that on a 30, 60, 90 right triangle, that say this is 30 here, and this is 60, then the side opposite 30, if it has length t, see that in blue, if it has length t, then the side opposite 60 would have length t root 3, and the side opposite 90, which is the hypotenuse, would have length 2t. So what this means is that sine of 30 degrees is going to equal opposite 30 degrees, which is t, over hypotenuse, which is 2t. And then, of course, we have cancellation here. You can divide the top and bottom by t, and we end up with 1 over 2. Cosine of 30 degrees is equal to the side adjacent to 30 over the hypotenuse. The side adjacent to 30 degrees is t root 3. The hypotenuse is 2t. And then we have cancellation here. We can divide the top and bottom by t. And we get root 3 over 2. Now for the last one, we're going to do tangent of 30 degrees. And that is opposite over adjacent. So that's going to be t over t root 3. and then we can divide the top and bottom by t. And then we get 1 root 3. And then we want to rationalize the denominator, so we multiply the top and bottom by root 3. And we end up with root 3 over 3. And that is it. Thank you guys so much for watching. I hope you found this video helpful.